Hey folks, I'm gonna get started in just a minute here. 10 seconds. All right, let's get started. Welcome to Study Hall, everyone. This is a place for you to bring your questions. If you have any questions, feel free to provide a link to the question from Learn or can be from somewhere else. I want to keep things constrained in general for now to beginner and intermediate Python topics, things that will pertain to sort of pre-TI prep to help get people past the TI. So if you have any questions regarding the material, anything that I can help you out with Python-wise, feel free to pop it in there. If you have any code or questions about code, you want me to debug something, you can put it in there. I do have to know what it's intended to do. Sometimes people will just send me code and say, what's wrong with this? And if there's no like syntax errors or something, you know, presumably it's failing some tests in Learn or on Code Wars or somewhere. And if I don't know what those tests are, if I don't know what it's intended to do, then I can't really help. So just provide a link so I can find wherever it's failing the tests. Or if it does have syntax errors, I can catch those as well. Yeah, and just feel free to ask whatever. Do please say hi when you get into the thread. Hello, somebody's saying, giving me a thumbs up. Hello. It's just good for me to see some activity in there, just so I know people are around, and yeah, it kind of keeps my spirits up a little bit. I do want to kind of issue a general reminder. I put something in the basic prep Slack channel late on Monday regarding the interview deadline. Just a reminder that the interview deadline is approaching. What is it, August 9th, I believe, if I have that correct. Oops. Oh, that froze up. Okay. Yeah, I believe it is August 9th. So just a few weeks away. So if you're looking to get into the August cohort, the time is approaching. So yeah, make sure you have your applications set up. Make sure you go through the coding interviews. If you're shooting for August, go ahead and go through the application process now. Start working on the coding challenges and schedule your TI as soon as possible. If you have questions about your readiness, to be clear, I would go do that, start that process or get that going and start pushing through that. If you have questions in the interim, feel free to reach out to me or Tovio or other members of the staff, and if you're in contact with an enrollment advisor, we're all happy and willing to help. If you do want to schedule one-on-one time with me, I'm open for that mid and late next week. Things are getting really busy on my end, but yeah, everything's good. Okay, cool. So that's general announcements out of the way. I'm not seeing any questions. Do feel free to pop them in there if you've got them. I'm just gonna start going through the material. We left off on strings last time, it looks like. At least I think we did. Is this? Okay, yeah, this is correct. Yeah. So this is describe the string type and cast values to strings. Okay, cool. And looks like actually we do have a question. So somebody's saying I'm having trouble figuring this one out. Okay, let's go to the link and I'll pull in your code. This is dictionaries lesson 6. This is the code as submitted. Value equals 16, okay. Dictionaries number 6. Is person old enough to drive? Takes in person. Okay, so let's see about this. Write a function called isPerson old enough to drive, given a person dictionary that contains an age key. Is person old enough to drive returns whether the given person is old enough to drive. Okay, so there's a kind of a class of, there's some similar problems to this, like earlier in Learn, where it's like, is like def is old enough to drive. I'll take in an age. So the difference here, you know, if I took in the age directly and I see this value at 16, so why don't I make a few tests for this real quick. Is person old enough to drive? Well, somebody who's 16 is old enough to drive. Somebody who's 15 is not old enough to drive, so presumably this should be false. This should be true. Somebody who's 2 is not old enough to drive. Somebody who's 36 is old enough to drive. Okay, so we got false, false, true, true. So with something like this, it's as simple as just saying return age greater than whatever the cutoff is, and which we know, at least in the United States or the parts that I'm familiar with, the legal driving age is 16. And of course that didn't work because I forgot to check equality. I could do that, or I could say greater than 15. Kind of makes sense to me to do greater than or equal 16 because, I don't know, 16 is the cutoff. So if the age is greater than or equal to the cutoff, then the person is old enough to drive. So the reason I show this problem is the difference here is really just the input. So the input here is intended to be, and this is why I strongly recommend always writing some tests as you're working. I see a value, just value equals 16 here, and presumably this is intended as a value to test the function with. And that's, you know, that's a good start, good place to start thinking about it. But if we do this, we have to, the great thing about writing a test is you have to pass the inputs, and when you pass the inputs, you have an intuitive sense of what those inputs are. So let's do this. So let's make, the input is a dictionary, remember? So in this example, the input was just an age, just an integer to represent an age, right? So that's why I showed this, is it's gonna be basically the same thing, except our input is gonna be different and the way we access that age is gonna be different. So let's say each person has a name, and name's not really important, but they also have an age, which is the important part. And I'm just gonna put in this name data because just to give me something to do. So let's see, Freddie, Betsy, Sammy, and Dave. Freddie, Betsy, Sammy, and Dave. So Freddie is 2, Betsy is 15, Sammy is 16, and Dave is 36. So all we want to do is just, we have this dictionary. Inside our function, this dictionary is called person. So, oops. So let's just return person, and we'll just take a look at it in these prints here. Excuse me. So this is person. This is the person dictionary. If it were me naming this, I think probably this is going to have you, yeah, it looks like it's probably going to require that you call it person. We'll kind of mess with this though. I might call this person dict though. And these might have, all might have various other fields in them, right? They might have different keys with different values also, but we know for sure that the input is always going to have a key called age. It might not always have a name. It might also have other information, but we know for sure it's always going to have a key called age. Okay, so all I need to do here is find the value at the age key. So I just need to access the age key. So just person dict sub age. Actually, just call that person again because I think I'm going to need that when I submit it. So person sub age, and now I'm just going to run my code. And the reason is, so let me back up a little bit. I'm running my code a lot to encourage you to do the same, right? Like make a change, run it, see what happened. Make a change, print something out. In this case, I'm making the change in a return. So since I'm printing the calls to the function, I know I'm going to see that return. So I know I'm going to see the change I made, right? But a lot of times, I'll print person sub age, just make sure I can see what's going on in there, and I kind of have a sense of what the change that I made, what effect the change that I made had. So anyways, okay, so this is just going to return the age, so I can just take a look at the age. Okay, so that's good. Now from here, I've got age, and now this problem turns into this problem. With this problem, it's just age greater than or equal to 16, and with this problem, I just access age as a key in a dictionary rather than as a parameter or as a an identifier directly. So we'll just say greater than or equal to 16, 1q6, which is not 16, and that's false, false, true, true. Freddie, who is 2 years old, is not old enough to drive, so that's false. Betsy is 15, is also not old enough to drive, so that's false. Sammy and Dave are 16 and 36 respectively, and are both, of course, old enough to drive. So let's just add that in there, run the tests, and we'll see. Okay, yay, I got it right. So somebody's saying it works in Replit. So this is a comment that I hear fairly often. So works is a little bit subjective because when something doesn't work in Learn, it may be valid Python, but it's not passing the tests, right? So behind the scenes in Learn, we have additional tests, not only to check, well, is it valid Python, but does it pass all the tests with the exact values that we expect for each test, right? So if we do something like this, and this is the original code as sent, it'll probably work in here. Oh, actually, oh, that's interesting. So is value necessary here? Yeah, so that's interesting. Perhaps you were passing something different as inputs, but yeah, this is actually not working in my environment. I don't know if you had additional code. One thing I just realized, and this is okay, this function is using something called value, which is not defined in the function and not given as a parameter. Given the constraints of this problem, we know for sure that it's only going to take one argument. So we can't add another parameter. If you want to use a value in your function, don't create a global variable and then just use it. The reason is somebody, like if it's just one problem that you're submitting in Learn, it's not going to really make a difference. But as a coding practice, if you define functions that utilize global variables. When somebody comes along, you or somebody else working in that code base, you're working on a code base of a few thousand or tens of thousands of lines of code, somebody can come along and just change the value of that variable, and then all of a sudden, that changes the way your function behaves. So I'm not exactly sure if you want to provide like any tests that you had. I'm not sure if you had any tests that you were using in REPL, but yeah, for me this is actually giving an error, and this would give the same error or a similar error in REPL too. But yeah, we can kind of try to debug from here. So stir object has no attribute values. It looks like that's happening right there. Oh, sorry, I thought I kind of heard something going on. Okay, so stir object has no attribute values. So I'm wondering, I know values is a dictionary method. So the way this code was written, person would have had to have been, it says for element in person, element would have to be a dictionary, so person would have to be something that contains a dictionary, perhaps a list. So, but we've now, the way this code is written, it won't work if I just pass a dictionary. So yeah, if value in element dot values, yeah. So that's one of those things where like you have to be sure that you're passing in the correct value when you're testing it. Hopefully that makes sense. Without having seen like your tests that you were using in Replit, I won't be able to be sure. So yeah, cool. You're welcome. Thank you for the question. I know dictionaries can definitely seem a little funky. They take some getting used to. I think it's safe to say, like, you know, like, I don't know, for the person who asked this, or for anybody who's like working on learning dictionaries, if you find it frustrating, you're kind of not alone. It's safe to say that they have like the most moving parts of any of the default built-in data types. Yeah. Oh, somebody's asking, do I want to see the tests? Yeah, if you want to send me the tests that you had, feel free. I'll plug those in, and that might give me some sense of maybe what was going on with those. Help you debug a little more. But yeah, whatever they are, you know, like this problem says, since it takes in a dictionary, if you're, I mean, you can just check this, and I don't mind checking it too, but you can just check this if you're not passing a dictionary as an argument, and that dictionary has an age key with a number that can be tested, then it's gonna cause problems. But feel free to send them in, and I'll take a look at them. You know, I feel like we should. I've got strings loaded up here. Let me just see if there's anything worth talking about with strings. Let's see. Let me go to this replit here. It's being sent. I think strings are worth covering a little bit, but then maybe let's pivot. I don't think we really need to get into the none type. Let's pivot and talk about dictionaries today, because I think a lot of people I get asked about dictionaries a lot. So okay, so it looks like, aha, yes, I do see what the problem is. So this is the full code as presented. So in this case, indeed, person is being passed into this dictionary, but this actually represents a list of people, right? So each of these dictionaries is a person. So this is not a bad, I mean, this could be a really cool way to test this function, but the way we would have to do this, first of all, I'd call this people, because the way that the problem in learn is conceived is that, the input is, oops, where is it? What is it, number 6? The input is intended to be a single dictionary, right? Whereas the input here is a list of dictionaries. And I mean, you could write it that way yourself, sure, but it's kind of like, what I'm seeing is it's kind of like you have parts of what I would call the driver code or the test code, like in with the solution, and there's just kind of a conflict there. So real quick, let's just go through this. Um, value, I'm just gonna comment out. We're gonna bake in 16. I'm probably gonna change some stuff in there anyways, but come back to that. So if I wanted to test all these people, I might say for person, or let's say for peep in people. So peep is a dictionary, and we can pass each peep. Let's just call it peep. Peep dictionary. Okay. We'll pass each peep dictionary into the function, and now we're passing in the correct type. So then from here, what I've done is taken this code out, and rather than for element and person, I'm doing for element and people, that kind of thing, or for peep dictionary in people. So that's where that for loop goes. And then if 16, so rather than checking for membership like this, I mean, we could do a control flow solution and return true or whatever. We could say if person sub age. Now, one thing here, this is age with a capital A. And that's a different key than age with a lowercase a. This is specifying age with a lowercase a, even though it would be more, grammatical to, I don't know, it seems like the data is nicer with the capitalized keys. In this case, we will lowercase it, right? Well, we can keep that one the same, but so we'll say if person sub age, if person age is greater than or equal to 16. Yeah. So we should see true, 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 false. Cool. And then let's do somebody who's also 16. I'm just going to do the same person. 16. True, 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 false, false. Oh. Oh, I meant to do equal. Whatever. Okay, so this person is able to drive. That's good. So we could do this, except that this is just a condition that returns that tells us to return true when the condition is true and false when the condition is false. So we can just return the condition directly, get rid of everything else, and then that just turns it into the code that I had. So I think it's actually cool that you did this. Just remember to like keep your test logic uh, clear of your solution logic, right? So here's your solution is just the function, and then your code driving um, the function down here. Keep it separated out. Okay, cool. All right, that was fun. I like getting into something like that. All right, strings or dictionaries. Let's do a little bit of strings and then um, hmm, let's just see what we've got here. Let's just see what's going to be next after. It's going to be basic operators, control flow. Hmm. 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 Dictionaries. Okay. Whichever. Let's just go through strings. So strings are a type that we teach fairly early. You know, it's sort of it's weird. It's like a beginner type. It's like one of the types it's one of the first data types that I teach people. And it's like one of the last ones that I think people master. I think strings are comparably complicated to dictionaries. Actually, I think they're the like working with dictionaries and working with strings are the two kind of big things. But strings can be easy. There's a lot of like common string things to do that are easy to deal with, but they are kind of subtly complicated. So a lot of um, a lot of programming comes down to string processing in some way, and that can get pretty intense. Um, yeah, it can be a lot potentially. So let's see then. This is just covering strings in a basic sense, though. So I'm kind of trying to get into a philosophical aspect of this that maybe isn't applicable. So simple string is we can just say hold a string in a variable like this. To make a string, we just delimit the boundaries of the string with double or single tick quotes. So we could do double tick quotes or single tick quotes. And these are both the same. So if I said, um, let's just call this text 1 and text 2. Let's call this world. So if I print text 1 plus text 2, I'm just doing this to show, because sometimes people will think, oh, well, you know, if a string was initialized with double tick quotes, it won't be compatible with a string with single tick quotes. And that's not the case. They are really exactly the same thing. It's just a matter of whether you can use double tick quotes or single tick quotes inside of the string, like as characters in the string. So I prefer to use double ticks because I find myself using the apostrophe, which is the single tick quote. So I find if I'm writing a string or something, I'll find myself using an apostrophe fairly often, whereas I don't find myself using double tick quotes inside my strings that often. So um, I use double tick quotes to delimit the string. That's what I like to do. Convention is to use single tick quotes though, so you can do whichever way you like, just as long as you have a good reason for it. Okay, I think we should just push through these challenges real quick and go from there. So below there are 3 variables, first, second, and third. Each of the variables has a string assigned to it. Concatenate the 3 strings in order and assign them to a variable called final string. I'm going to do this. Copy these. And what is this? Is it that? Yeah. Plus, okay, so we just concatenate. Concatenate is just a fancy name for adding when it's a string. When we use the plus operator on a string or a list or a tuple, we call it concatenation rather than addition. We just add the strings together. That gives us the strings concatenated together, and then final string. Okay, looks like this is a similar thing here. Oh, what happened there? I think I'm gonna have to do something a little different with this, but whatever. The following challenge, there are 3 variables, first num, second num, and third num. Each of these variables has an integer assigned to them. The point of this exercise is to concatenate the numbers together and turn the result back into an integer. So if actually, it'll be faster if I do this. Oops. And so we're going to concatenate those, turn it back into an int. And run it. Cool. So notice, right, like I had to turn these into strings first because I didn't want the sum of these numbers. If I hadn't turned them into strings, it would have just summed them, right? Let's just do this. Or here, I'll do it this way. Print final num. All right. So cool. So what we wanted is this first one, and if we had just summed them, if we just add them together, right, that's just going to give us the sum. So the sum of 1, 2, 3, 4, 5, 6 of 123, 456, and 789 is 1,368, evidently. Whereas if I concatenate those, if I cast them as strings, concatenate the strings, and then turn that concatenation into an integer like this, recast it as an integer, I get whatever. What is that? A 9-digit number is that 10 million, 100 million, 123,456,789. Anywho, let's do something like, oops, that. Okay, last one. Write a function called done. This function will take 3 integers as arguments, n, m, and p. N, m, p. Okay. And combine them into a single 3-digit integer. Your function should make p the first place of the number, m the second place, and n the third place. Okay, weird. So I'm going to do something with these. So these are numbers. So I think, I could do like an F. Let's do something. Let's do something slightly fancy. Okay, so I made an F string, and I'm just going to turn that F string into an int. Alternatively, we could have done stir p plus stir m plus stir n, cast that as an int, and that would have worked as well. Just for fun, it just occurred to me, I think I can do, like a join. It's kind of feels a little silly. Yeah, join. Let's do join map stir. We want to map the stir function to the tuple containing p, m, and then n. So that's also going to work. I think this is, I don't know, I like that solution better. The original one, the first one I did. Never hurts to solve a problem more than once. It's funny, I think this is, a little pro tip for you. Like, when I go, when I approach learning another language, which is something I do fairly often because I like to learn different programming languages, and that's really not a brag. Once you know one, you learn the second one, and you're like, oh, I can't believe I'm doing this again. This is weird. And then you learn the third one, and it's easy. So once you learn one programming language, you learn a second one, you think it's going to be hard, and it's actually like a lot transfers. You just kind of learn different syntax, like just a different way to do things in the same. It's like you take the same steps in a lot of languages, or the problem-solving processes are kind of all the same. So when you're learning your first language, you're not only learning the syntax, you're also learning the process of problem solving in a programming language. So you're kind of learning two things at once, right? So once you learn that problem solving process, it transfers really well. It'll transfer really well to other languages as well. So especially with Python. So Python's a great like jumping off point because has similarities to a lot of other. It's a C-like language, and a lot of modern languages are C-like or feel C-like in some way. Um, so it's of a family of languages that's ubiquitous. I think it's safe to say that C-likes are probably the biggest family of languages. So um, yeah, it's a great first language to learn, and it's just a good language to know anyways. So sorry, digression, digression alert. When I go learn a new language, like what I'm learning is, some problem solving things, because there are little differences. In C, you really have to think about like memory allocation in a way that you just don't ever have to think about in Python, in a language like Python. Um, so that's something you have to kind of learn to navigate. Um, there are some slightly, different things that I have to do, but more or less I'm just learning different syntax if I'm learning a language. So what I do is I just try to implement like functions to problems that I already know the answers to. Like I try to write factorial. I have like a catalog of functions that I can just write off the top of my head, like mean, median, mode, factorial, uh, permutations, combinations, binomial PMF. Um, what else? I have a whole bunch of prime functions that are fun to play around with, like is prime, next prime, nth twin prime. Um, then there's anti-prime numbers, which are highly factorable numbers, which are basically anti-primes. So like writing functions to find and analyze groups of prime numbers or anti-prime numbers, or spaces between prime numbers or anti-prime numbers, which are called prime windows or anti-prime windows. So things like that, right? So I know how to do all that stuff in Python. I've done it dozens of times just to like practice my chops, or just to play around and look at prime windows or whatever. I'll get curious and just start messing around with something like that just for fun. So um, when I go learn a new language, I just do I just try to implement those things correctly in that language. So the reason I'm saying this and taking this long to say it is I don't want you all to like think if you've solved a problem that you shouldn't solve it again. Like it really helps to reinforce something, and I think for probably most people, um, you actually don't really remember code. If you write a solution to something, wait 24 hours and see if having seen that solution really made a difference. If you can go write it again, sometimes it's easier. Usually it is. Sometimes it's harder. Sometimes you remember little things and you kind of get to solve it again from a different perspective. So yeah, I don't know. I'm taking this long digression to say, you're going through the problems and learn. If you think of a few ways to solve something, um, put them both in, and you can just comment out, leave your favorite one uncommented, and then you can kind of go back and reference different ways that you did something. So learn will save your solution, so you can go back and reference, how did I do that problem. That's how you can do that in learn. Ultimately, how you can do that on your local machine is, I have this notes document. I've talked about this notes document, and this is, where is this? Oh, I'm up to 60 or 6,254 lines in this document. So this usually takes me, I don't know, a few, I don't know, 4 to 8 weeks, maybe 6 to 8 weeks to fill one of these up to about 10,000 lines. And then I just archive it. I have a little archive folder that I just throw all my old notes documents in once they get to about 10,000 lines of code. once they get that big, it starts slowing my text editor down a little bit. I start to feel my text editor lag a little. And it also just becomes kind of like stuff that I did a long time ago that I'm not likely to search for again. So I wipe it out and make a new one. So saving all your stuff in like a document like this can be actually, it seems like an insane thing or something. It seems like not, like it's not going to be helpful, but um, I found this useful, and Tovio does the same thing. I know Tovio will encourage people to do the same thing. Just take all your notes in a single document, or do all your work, whatever. I'll usually do my work in this file, and then once I'm done with it, you know, for example, at the end of every study hall, I just cut that and then paste it into my notes document. And then obviously I have little usefuls here. These are things I might paste in if I'm, you know, just want to really quickly paste one of these in if I'm working with a student or something. But anyways, okay, spiel complete. Tangent over. Hello, we got a newcomer or somebody who's just saying hi right now. Hello, welcome. Okay, anyways, I'm just laughing at myself because that's, I know that was a long tangent, but yeah. The takeaway there is definitely giving things multiple solutions can be helpful. That's all I meant to say. Only took me 15 minutes to get there. Okay, the none type. I don't know. Let's move on to, I kind of want to do dictionaries because I feel like I got a lot of questions about dictionaries. People love dictionaries. They hate dictionaries. The people want to know about dictionaries, basically. That's the deal. Cool. So by the end of this lesson, you'll be able to describe the concept of a key value pair, recognize and describe a dictionary. So we're jumping ahead a little bit. So if you're feeling like more of a beginner, I do welcome you here, and you know, this is something that maybe you haven't learned yet fully, but something that you'll be getting to soon. So I recommend you stick around and watch through this, even if it feels a little, even if you're not quite to this point in our material or in your learning yet, because you'll get here sooner or later, probably sooner. Okay, so dictionaries. So I'm going to presume some understanding of lists with this, but let's just go quickly over a list. Let's talk about lists really quick, and then we'll get to dictionaries. So a list, as I know some of you, at least some of you know, a list is just a collection of elements. Okay, so let's just make some elements. Your list has elements in it. You know, nothing super fancy going on here. If I want to add stuff to the list, list.append. Hello, I'm going to add whatever elements I want to the list. Pretty straightforward. So one nice thing about a list, I put things in the list, and then depending on where they are in the list, i.e. their location is a word that describes where something is, right? So depending on where they are, left to right, in the list, they have an index automatically assigned to them. Every element in the list has an index associated with it, and I don't have to do anything for that index. I didn't have to say, you know, hey, make sure to put 44 at index 0. The first element is given the index of 0. It's just kind of funny if you're not used to counting starting from 0. It can be a little weird, but Python is a zero-based indexing language, so which is typical of most languages, at least that I've seen and know about and have learned. So, excuse me. So whenever we initialize a list, we just put the elements in, and the indices are automatically assumed for us. We don't have to do anything for those. If I want something at a certain index, I just place it at that location. So if I wanted 44 at index 2 and 77 at index 0, I'd have to take 77 and put it there, and 44 and put it there. Right, so that's 77 is at index 0, 22 is at index 1, 44 is located at index 2. Oops, and I'm getting just all kinds of notifications that I don't, okay, sorry, clear those away. Oops. Okay, so I want to establish this idea because I think when people learn lists, this is kind of an intuitive thing, right? This is something that usually lands pretty well, more or less, you know, indices take a little getting used to. But it's generally something that I see people glom onto pretty quickly. And there's something similar with dictionaries, and I'll get to that in a second. So each element has an index. And if I want to access that in an element and I know the index, I'm just like, hey, what's the element that's located at index 1? That's going to be 22. What's the element that's located at index 3? That's going to be hello, right? So I added this hello, so now the list has 4 elements, so it has an index 3. If I try to access an element that's you know, like index 6, there's no index 6 in this, so I get an error. It's a index error. It says list index out of range. So lists have indices, strings. Strings have characters as their elements, and each character in a string has an index associated with it. So strings have indices. I could index into a string and get the character at that location. We can use indices to slice a string or a list. A tuple is a lot like a list. It's just an immutable list. It's really a very similar data type. It's just if you take a list and just remove the mutable aspects of it, what you're left with is a tuple. So lists and tuples are really similar. Strings also have indices, and we can index into those or subscript into those and slice into them as well. And a slice just gives us rather than giving us a single element, it gives us a sublist or a substring or a subtuple of the list of the object that we're slicing into, right? So that's lists and indices. Okay. So presumably we have this idea of of indices corresponding with elements in lists. So dictionaries aren't much different, except that we have to supply, they don't have an index for one thing. They have something that's an alternative to an index. And instead of it automatically being given, we have to supply it. We have to tell the dictionary what we want how we want to describe that location. With a list, we just stick stuff in it and it automatically has a location. That's not the case with a dictionary. We have to put in values and associate those values with a key. So the key in a dictionary is the alternative to an index in a list. So index is to list as key is to dictionary. The big difference is that with a list, we don't have to manage the indices. They're just automatically given. We just have to manage the elements. We just have one set of things to manage, and that's pretty easy. You're just either adding things into the list or somehow removing things. You're accessing elements perhaps based on knowing the element, and you're accessing the index of that element with the index method, or you're accessing elements at a given index by subscripting, which is what I showed earlier. So with a dictionary, it's like instead of an index, I have to supply a key. So I have to say, let's say 0. Let's just do this. 0 is 77. So that's one entry. So one entry, one item in a dictionary contains a key and a value, right? And I separate the key 0 from the value with a colon. So key colon value, comma, key colon value, key colon value. So let's call this 1, let's call this 2, and this will be 22 and 44. Print DCT. Okay. Okay, so my initial starting dictionary is somewhat similar to my initial starting list, right? I gave these rather than the numbers 0, 1, and 2, I gave the strings 0, the strings of the words 0, the word 1, and the word 2, right? So obviously there's a difference there. And I just wanted to highlight that, right? Because I can name these keys whatever I want. Just like it wouldn't, think about like, what would it mean to have two elements in a list that were both at index 5? Maybe it would mean that like the element at index 5 was like a tuple that held two elements, or a list that held two elements. But that's not really two elements that are at index 5. That's one element that just holds a couple things. So it doesn't, you can't have, in a list, you can't have two of the same index, right? You can't have like, this can't be at index 1 and this at index 1. So you only have one of each index. Same thing with a dictionary. You can't have two of the same key. So let's just say, I'm going to just change the keys a little bit. We'll just say A, B, and C. So I'm going to change my keys to A, B, and C. So let's say I change this to B, and I'll give you a second to think about what's going to happen here. It's always good to like, take a guess, like see what your intuition tells you. Maybe it doesn't tell you anything. Maybe you're like, I don't know what the heck that's going to do. We've got two B's, and you're telling me that it can't be that way, that that's not going to work. Maybe this is going to give you an error. Maybe your intuition tells you that Python's going to throw an error here. I tried to add a B here, and then I tried to add a B here. Maybe one overrides the other. Maybe the second one just overwrites the first one. Or maybe creating the second one just fails and nothing happens because it's like, oh, well, I can't create 44. I can't put 44 at the key B because, B already exists with 22 in it. So just think about that for a second. You can share it in Slack, put it in Slack if you think you have a intuition on what it might do. All right, let's run it. So it did one of the things I mentioned. It overwrote, right? So the one that I made later just overrode the one that I made earlier, right? And that's what's going to happen. Okay, so so with this list, if I wanted to access this 22 in the list, I would have to say list sub and subscript into the location of that 22. Now the locations in a list are described by numbered indices, right? The element 22 is located at index 1 in the list because 0, index 1, right? So if I wanted to access 22 in the list, I'd have to say list sub 1, and that would give me 22. If I wanted to access 22, the value 22 in the dictionary, think about what I might have to do for this. And it's very similar. It's like the same syntax. It's exactly the same, except you use the dictionary style location, which is the key, instead of the list style location, which is the index. You can think about what that's going to do. So if I wanted to access the value 22 in the dictionary, I can't use an index because, like I said, dictionaries don't have indices. No index. If I try this, I'm going to get a key error. It says key error 1. And I'm going to say, generally Python errors are pretty well written. They're fairly descriptive as languages go. That it's Python is known for having pretty good errors, pretty helpful errors that help you figure out what's going on. But a key error, it doesn't really tell you much, does it? So when you get a key error is an error that applies to a dictionary. When you get a key error, it's trying to tell you that 1 is just not a key in some dictionary, and it'll point at where it's trying to do that. So if you get a key error and it just says something, you just have to know that that means it tried to use that as a key and it didn't find that key in the dictionary. And if you try to use something as a key to like subscript into a dictionary that's not a key in the dictionary, then you get a key error. So you just have to know that that's what that means. So I have to tell it the location of 22, and 22 is located at B. Just like that. Okay, so that's how I can access things. But what about in this list, right? I added something to the list. I added that hello. So what's the analog in a dictionary? So a lot of times you'll see people say, oh, well, with lists you have append, and with dicts you have dot update. And I don't like to use dot update. I don't recommend that you use dot update. It works a little different. I'm gonna show you a way that I prefer, and I think overall it makes more sense. So if you see people telling you to use dot update, that is some people's preferred way. There are some applications for dot update. I think of dot update more as an extend than an append. So if I just want to add something into the dictionary, what I do is I say d sub, and I have to give it a key. So whatever the new key name. So let's say ABC. Oh, the next one is D. So dict sub D equals, and now I can just assign, even though this dict sub D doesn't exist yet, I can assign something to it. So this won't give me a key error. So I can say dict sub D equals, let's just follow suit with the list. I'll just add hello into it. So that'll add hello. So this is what I would consider the analog to an append. Notice you have to know what key you want to name it, right? Maybe this is a variable or some, maybe you figure that out in your code, however you figure out what your dictionary keys are going to be. But I have to supply somehow a name for the key, and a value for the value. Now I'm using strings as keys in dictionaries because, for one thing, it's different, just to kind of show you, well, with a list, I'm stuck with numbered indices. With a dictionary, I can use strings. But I don't have to use strings as keys. I can use integers, I could use floats. I can actually use any immutable type. So an immutable type is just any type that won't change, that can't change. So I can use strings, and another reason I'm showing you strings is it is really typical. I think it's safe to say that it's usual that when you're writing dictionaries, you're going to use strings as the keys. You can mix and match types for the strings. I don't know. I can't really. My hunch is that if you're doing that, you're maybe maybe need to think about how you're structuring your data, but I don't know. There could be use cases there. Um, so you can use any immutable value for a key in a dictionary. And the reason you're limited to immutable values for keys is, so take a list, for example. You can't use a list as a key in a dictionary because a list is mutable. It can change. A tuple is a list that that is just immutable. It's just an immutable list. We give it a different name and we use parentheses and make it sound like it's something way different than a list, but it's not. You can think about a tuple as, and a list as basically the same thing. One's mutable and one's not. And there are some other implications of that that cause some other differences. One is that you can use a tuple as a key in a dictionary because a tuple will never change. And you can kind of think through that, like, what would it mean if the key in your dictionary just changed, right? That would make it hard to anticipate how you would access the value at that key, because it's now that it's not the same, so that could cause a lot of problems if you were mutating a key and then trying to access that later. Like, how would you know what it was, unless you just knew what it was somehow. But anyways, so you have to use immutable types because you know what they're going to be. That's one explanation for it anyways. There's sort of a more technical explanation, which is that dictionary keys are run through a hashing algorithm. And that makes searching through a dictionary very fast. It makes finding an object in a dictionary, I think it's an is it an O of 1 operation? I always forget if it's O of 1 or, yeah, it's got to be O of 1. So searching through an element in a list is an O of n operation, which means it could take as many times as, as many attempts to find an element in a list as there are elements in the list. Whereas when the keys in a dictionary are hashed, the way it looks up elements via the key only ever takes one attempt. So even though dictionaries might seem a little clunky or something, right? Like there's more to them. They have the potential to be very fast at scale, right? So if I have a list with millions of records in it and a dictionary with millions of records in it, I might choose a dictionary because finding a given record only takes one attempt in a dictionary every time, whereas finding a record in a list takes potentially as many attempts as there are elements in the list. So dictionaries are awesome. We got a question. If we're using an existing key, would it just update the value? Oh, perhaps I think maybe I answered that with this. Sorry, I think there's like a minute or 30-second or a minute delay between when I talk and when people uh, hear me. But yeah, um, used an existing key. Would it just update the value? Um, yeah, I think maybe I kind of already answered that, or I'm not understanding the question. But yeah, okay. So let's just make some bullets here, make some bullet points here. So initializing, oops, uh, nope, keep hitting that wrong hotkey. Initializing, um, adding elements, just trying to like kind of label each parts of these. Um, let's call this accessing elements. Call these values. In a list, we call the elements elements. In a dictionary, we call the values values, but they are the analog to each other. So a list has elements, or it has indices and elements, and a dictionary has keys and values. There's one more that I should add, which is updating an element. And this is why I kind of like this syntax. So updating elements. So if I do this, let's just say list here, and then I'll say list sub let's change 44, so let's change index 2 to world. And let's change the same thing. So let's do C, we'll change to world. So you can see here's how we initialize a list. Here's how we initialize a dictionary. Printing is obviously the same. Here's how we add elements to a list with append. Adding elements to a dictionary, I prefer the dictionary sub key equals sub new key equals new value. Accessing values is basically the same. You know, you just use the location schema of indices for lists and the location schema of keys for dictionaries. But one thing that I see people do is they'll try to use curly brackets to like key into a dictionary. You won't be able to do that. So it's still square brackets to subscript into a dictionary to access an element in a dictionary, but you just put in a key instead of an index. Pretty straightforward. Updating elements in a list and in a dictionary, kind of the same thing as accessing, right? Because we'll just say list sub the index that we want to alter, and then the value that we want to, the new value that we want to give it. And then same thing with a dictionary, except we just use a key instead of an index. So dictionary sub key that we want to alter, and then the new value that we want to give it. And then print it off. So that's dictionaries in a nutshell. Cool. Excuse me. Awesome. I'm just wondering if there's anything. I guess I should add the note, right? Like additional things to know. Oh my gosh. Dictionaries. Additional notes on dictionaries. Keys can only be immutable types. Let's prove that. I mean, the proof is just that it's going to give me an error if I try to do something else. If I try to say D equals a dictionary where the key is a list of 1, 2, 3, and the value is hello, this is going to be no go. Unhashable type. Mutable types are unhashable. It's not really like they can't be hashed. It's just that there's no point because it'll hash the list, and then if the list changes, the hash no longer applies. So it's just like it's like I could do that, but I'm not gonna. That's basically what the deal is there, or that's my understanding at least. If there perhaps there's another reason, but I don't know. So if I try to do the same thing with a tuple, this is totally fine. Oops. That's totally fine. Okay. Just like with, I'll do this. I'll say, just like with lists, I'll say, just like where lists can't have a duplicate indices, i.e., well, I'll just leave it there. Duplicate indices. Duplicates of the same indices. I should give an example. E.g., there can't be 2 index 5s and 1 list. A given list. List. Okay. Dictionaries can't have duplicate keys. Duplicates of the same keys. Oops. There we go. And let's just do something similar, e.g., there can't be 2 key A's in a given dictionary. Cool. Anything else of importance? Am I forgetting anything? I feel like I am, but I just kind of always feel that way, so, whatever. Let's just go through the challenges. All right. Which of the following data types cannot be used as a key in a dictionary? It's going to be list. Where's list? Oh no. Dictionary. So dictionaries are a mutable type like a list. Dictionaries and lists are both mutable. We can't use dictionaries as keys in dictionaries. I didn't demonstrate that, but if you're wanting to do that, if you're wanting to use the dictionary as a key for your dictionary, that's a good time to stand up and take a break. Get a drink of water. Dictionary keys don't need to be unique. False. They do need to be unique. That's the whole bit. That's just another way of saying this whole thing about can't have duplicates. Just like, so we'll say list indices are unique. As are dictionary keys. What types of data can be stored in dictionaries? All of the above. We can put anything in a value of a dictionary. We could put a dictionary as a value in another dictionary. Again, there's sort of implications of the complexity of your data, how complicated your, data is going to get by doing that, but I don't know, time and a place, probably. Declaring dictionaries, we kind of went over this. D equals a dictionary, we can just do curly brackets, just like declaring an empty list. With square brackets, we can declare an empty dictionary with curly brackets. Just like that. Declaring values inside the dictionary. I'll show something here. This is fairly common to do. When I actually include these up here. Okay. It's fairly common to want to format your dictionaries in some way. So there are various ways to do this. And I prefer this way that's being shown. I actually prefer, I don't know if they're doing it though. Oh yeah. I think it's standard to do this, but I actually prefer that way. And then the comma at the end, just to make things kind of nice and tidy. So you can break up your dictionaries across multiple lines so that there's only one element or one key value pair, one item on each line. And that's a pretty common thing to be able to do. You can actually do the same thing with lists, although you don't see it as much because they're not as visually complicated. This makes reading the code where I'm declaring the dictionary easier, as you can probably see. Let me see if I can. Oops. I mean, I guess it's not terrible either way in this case, but it can get more complicated, and it can get even more complicated. The syntax highlighting is pretty good, but if I made all of these strings, right, it becomes visually less clear where something starts and stops and ends and whatever. So breaking things out onto multiple lines is suggested to aid in readability. this is kind of an interesting thing. Let's do a bit of an experiment here. So lists, here's another, this is, I think this is the thing that I think I was thinking about when I was thinking, oh, I feel like I'm missing something. So order. So if I have, let's do this, lst1 equals 33, 44, 55. And let's do lst2 equals 33, 55. Are these lists equal or not equal? And I'm going to do, before I run this, I'm going to do the same thing with dictionaries. So let's do oops. Let's say A, B, C, and let's do the same kind of thing. Oops. 33, oops. 33, comma, 44, 55. Okay. So let's just change the order of these. So just like with the lists, are the dictionaries going to be the same or different? And I'm strongly alluding to the answer here, but you know, ask your intuition. What does your intuition tell you? And like I said, it's always good to take note of your intuition. That way you know how to cultivate it and make it better. Okay, so list 1 is 33, 44, 55. List 2 is 55, 44, 33. Same elements, different order. False. Lists are not equal. Dict 1 and dict 2 contain keys A colon 33, B colon 44, C colon 55 in different orders. Are they going to be equal? This is the crux. What's your intuition tell you? So these are equal. These are the same value. They are different objects. They will have different IDs. If I do the IDs of these, will be different because they're different objects. But they have the same value, in, according to Python. So this used to not be the case, but recently, at least recently to me, as recently as December of last year, 2020, or around November, December of 2020, dictionaries will retain an order. So if you, they will retain the order that you place elements in them, right? So if I place in A, C, B, D, they will retain that order, for example, when printing them out or when looping through them. But there's no way to change the order. So even though you'll see dictionaries kind of act like they have an order, the way we think about them is as not having an order. Lists when we think about a list, we regard the order of the elements as very important, because if that changes, the indices to refer to those elements changes. Maybe we want to do that, maybe we don't, but either way, it's significant. It's meaningful in the list. The position corresponds to uh, its index, right? Whereas the position in a dictionary doesn't correspond to its key. You explicitly give the key, so whatever. So I can't access elements in in order in the same way that I can with a list. Um, so we call dictionaries an unordered type, even though if you make a dictionary and you print it out or you iterate through it, it will iterate through the elements or print out or it'll iterate through the items or print out the items in the order that you put them in general. So even though you'll see that, just remember we think about dictionaries as not having an order because they don't have indices. An indexed type has an order and a non-indexed types does not. So indexing and ordering go hand in hand. They're kind of different words for the same thing. Cool. Well, that was pretty quick. This is our normal stopping time. I'm going to spin down and grab a little break before lecture tonight if you're in premium prep, and I'll see you in there. If not, then I'm going to be taking Friday study hall, and I think Tovio's got all next week as well for study halls. Let's see if there's anything else. Thanks to everybody who brought in a question, and I appreciate the interactions. Yeah, I think that's what makes study hall kind of lively and fun, at least for me. So thanks for that, everybody. Look forward to seeing y'all around. Don't be a stranger. Please do feel free to reach out. Send me a direct message on Slack or just at me somewhere if you have any questions. I'm fairly busy recently, but you won't be bothering me. It just might take me a little bit to get back to you. I am absolutely happy to help people if you have any questions regarding Python, regarding getting ready for the TI. My ability to answer all questions related to the DSI itself is a little limited, but I'm happy to chat about it and give you my 2 cents on whatever. And if there's something that's out of my wheelhouse, I will know who to send you to. So don't be a stranger. And I hope to see all of you around. Best of luck getting through your technical interviews. And yeah, I guess I got to wrap it up somewhere. Cool. Bye-bye.